Hello, everybody. Thank you for joining us today. This is our SAA webinar around Back to Basics. So I am Alex Rybak. I'm the Senior Director of Product Management. I run our open source program office at Revenera, and I'm part of the cybersecurity team. And along with me, I've got Michael Dolchek, who runs our consulting services team. And together, we really want to kind of get back to what a lot of our customers are asking for, which is let's get back to basics of open source and SCA. The thing that we have seen recently is there's been a lot of new people brought into having to use various SCA tools, dealing with open source, dealing with cybersecurity matters. And a lot of these folks may not have had, this be topics as part of their education when they were in college, as well as onboarding when they joined their respective teams. So there's a lot of interest for kind of getting back to, what is open source, what are open source licenses, open source security topics, regulation topics, things like that. So we wanted to put this webinar together to be able to address those points. Today, we're really focused on three topics. One is going to be an open source SCA and open source program office refresher. So we'll get back to kind of definitions and what these terms mean and the various tools involved. Then after that, we wanted to talk about industry and regulations, let you know what's happening in the software industry related to these topics, various regulations and where they stand, and things that may impact your teams. And then Mike is going to talk about our various services offerings and how we can help if you are just getting started or if you want to accelerate this work on behalf of your company. So a couple of housekeeping items. So this is being recorded, and a recording will be made available in a few days. Also, there is a chat tab, so please post any sort of comments or questions, and we will handle them as we go, and we'll handle the rest at the end of the presentation. So please engage with us and let us know what you think and any questions that we may answer. Okay, so with that, let's get started. So the first thing where we really want to start is, what is open source software? How is it different from commercial software? What are the different elements that require you to consider governance and treatment a little bit differently than you would with traditional software that you buy? So if we look at kind of what is the definition of software, what's comprising of the software package, it clearly has source code, which gets compiled into object code. There's a set of instructions. There are APIs that you may interact with. Typically, applications handle data. There are specifications. And usually, there is a vendor that is responsible for the software. And if you happen to be buying the software, you typically have a support and/or maintenance contract, which allows you to reach out with any questions, suggestions, or any troubleshooting. When you look at open source software, it is a little bit different. So it comes with freedom, and it's really freedom as in speech, not as in free beer, right? So what we're really talking about is you have freedoms, what you can do with a software that you typically don't have with commercial software. So you have freedom granting you access to source code. You have an ability to modify, distribute code, to create derivative works. And all of this freedom comes with obligations and responsibilities. So you have a requirement to protect the integrity of the author's code. You don't want to misrepresent other people's work as your own. You want to make sure that there's attribution, giving them credit. There's cases where open source components require you to disclose what modifications you made, or there's requirements on certain types of licensing downstream if you are going to be reusing open source packages in your commercial software. The other important element of open source is lack of discrimination, right? So no discrimination against persons, groups, or fields of endeavor. So there's constraints on what it could be an open source license depending on what limitation the license includes in its terms. The other really important thing to understand is open source is not the same as public domain. Just because something is downloadable from the internet doesn't mean it is an open source package. And publicly available is not the same as being in the public domain without any requirements. And we'll talk more about that. Oops. So I did want to spend some time on what we see as common misunderstandings around open source. So first of all, and this is really important, is just because something is available to download doesn't mean that you automatically have permission to use it. you need to make sure that everything you are using has some sort of usage terms along with it. If you have a package that you want to use in your development and there are no licenses available or there's no usage terms, make sure that you do your research, work with your legal team, and understand what obligations you incur by using that particular package. As we just mentioned, freely available does not equal open source, and public domain is different than open source. So there's a misconception there, again, that just because something is available, you just grab it and use it. That's not the case. You need to read the license and make sure that you comply with it. Even if you don't ship your products, if you have a hosted solution or maybe something is for internal use, if you are using open source components, there are still compliance tasks that you need to do. So again, work with your legal teams, understand your policies in your companies, and make sure that you are complying with them. And the other kind of big misconception is when you buy a commercial package from any of the large software vendors or any other software vendors, that it does not contain open source. That's not true. There's lots of open source inside commercial software, and that open source also contains the same obligations as if you are directly using that package. So you need to make sure that whenever you're buying software packages, that you are receiving all of the obligations that that company had to fulfill, and make sure that you are compliant in your own use of that software package. So what we have seen now is that open source has really hit mainstream. We have been keeping records for over a decade now on open source use, and whenever our services team does any sort of customer audits using our products, so whether it's in a M&A context as part of technical due diligence, or whether we have a new customer that wants our services team to come in and help them kind of get baselined, scan everything, audit everything, and then they will take over, we keep stats on all the work that we do. And you can see here, there's kind of a bar chart indicating the numbers that we have been seeing over the years. So we typically see developers leveraging open source in their work, right, to speed up time to market and to drive innovation, not to really waste time on constrained implementations or kind of challenges that have already been solved in industry. So if you look at the chart below, we really kind of see three areas where there's been a big leap in the use of open source. So if we go back to the mid-2010s, so 2014 and 2016, we saw a doubling, actually more than a doubling over a 2-year span, because package managers really began to gain adoption. And whereas in older languages, a developer may take some code, put it into their code base, and then statically compile everything, today, the way that most developers introduce third-party content is through third-party dependencies, manifest files, where you declare what dependencies your application requires, and then downstream, those dependencies have their own dependencies, and you end up with a big tail of direct and transit dependencies coming into your product. Since the use of package managers, we're really seeing a pretty significant explosion in the number of items that we typically see in audits that we do. The second real big bump came in 2019, 2020, where we saw a 200% increase year over year. And what we really started seeing was increased popularity in ecosystems like PyPy for Python, NPM, Ruby Gems for Ruby, and so forth, where a lot more dependencies are being brought in. Whereas in the past, there was a handful of really large monolithic third-party libraries, we saw a lot larger volume of libraries and just smaller size. And then kind of going forward a couple of years, we saw another big increase because we now saw a lot more components, significantly smaller, and a lot more abstraction into smaller third-party components that can then be brought in as need arises versus bringing in a huge library and only using a small portion of that code. Looking forward, we're kind of flat between 2022 and 2023. But given how much we're seeing developers using Gen AI technologies, code suggestions, and so forth, we do expect to see a pretty significant increase at the end of this year in 2024, just due to the fact that we're seeing a lot more generated code in the code bases that we scan. So let's talk about open source licensing. So whenever we talk about open source, there's really kind of three elements that you need to think of. So you need to think of legal risk and making sure that your corporate policies comply with the open source requirements and that you are using things kind of commensurate with what your policies define. You need to consider the security ramifications. So if you're using code written by somebody else, is it secure? Does it comply with your security policies? Has there been as great of a standard of care applied to it because ultimately the software you sell is yours, your logo's on it, your company's on it, and it's your obligation to make sure that it is secure for your customers. And then the third thing you really need to consider is reputation risk. Right? You don't want to be in the articles when a new kind of well-publicized vulnerability is recorded in the news, and therefore you want to make sure that you have your house in order when you ship your software to customers. So number one rule when we talk about open source licensing is absent a license, you do not have rights to use the software. So you need to make sure that you understand what is the licensing between any package that you're using, and make sure again that the requirements of that license comply with what your company policy is. And if you don't have a company policy, step number one is work with your legal team, security teams, and develop a policy for use. Now, you don't have to have one policy for the whole company. They can vary by business unit, by teams. You can have a conservative policy across the organization, and then perhaps there's exemptions product by product as the need arises. But make sure that you have overarching rules by which your development teams need to work so that it's kind of consistent across your organization. So when we talk about licenses, there's really kind of two elements to it. Number one is understanding what a license trigger is, right? So what is an action taken by you as a development team using somebody else's code that would trigger requirements in a particular license or obligations? Typical triggers would be modification. So are you modifying somebody's code? If you are, the way that you treat the modifications may be different than the way that you treat other code in your application. How are you linking? Are you statically linking? Are you dynamically linking? Depending on that, there may be requirements in the license that become mandatory versus a different type of linking. And distribution, right? Is this something that you're hosting? Is it something that you are distributing or sending out to your customers? Is it an on-premise installation? Do you have a SaaS application, but maybe there's a mobile phone client, so there is a distribution happening onto the phone. So it's important, again, to understand the nature of the product that you're building and how it's behaving in the field. When we look at the types of licenses, there's various buckets. So we start with permissive licenses. These are ones that have minimal requirements and allow software to be modified, distributed with very little effort and burden placed on the organization doing so. On the other end of the spectrum are copyleft or network licenses, which, depending on how you're using that component, depending on how your application is deployed, there are more or less requirements that you have to follow. So again, work with your legal team, make sure that you review what your company needs to do in cases of permissive licenses, prohibitive licenses, copyleft network, to understand what it is that your company allows and what are the obligations that your company imposes on you to make sure that you're complying with the terms of the license. Other thing to understand is there are many licenses out there. There's hundreds of licenses out there. There's about 130 that are recognized by the Open Source Initiative as open source licenses. SPDX, which is run by the Linux Foundation, they've got over 625 licenses on their site. So make sure, again, that you look at these and you understand what these licenses entail. There's also a lot of licenses that are written by developers, right? Things like the beerware license, where you have to provide developer a beer. There's the JSON license that has a for good not evil clause. So that's one that legal is always interested in, is how do you interpret evil, right? It's military use evil, is used for nuclear facility evil, right? So it's, again, important to understand what are you building, whom are you selling it to, what industries do you play in, and are there any sort of limitations or prohibitions in the license that may prevent you from using somebody's intellectual property. Okay, so now that we've talked about the legal side of it, let's talk a little bit about security. So I really want to focus on application security, right? So when you look at overall, we've got network security, we've got making, security on how your application is developed. The part that is relevant when we talk about open source content is application security and what goes into your product and what processes do you follow to make sure that your customers are receiving secured applications from your organization. So the simplest way that I like to talk about this is if you look at the pie chart on the right, there's kind of three categories of testing or considerations that need to be made when you're talking about application security. So the first one is SAST, which stands for Static Application Security Testing. This is essentially what you focus on the proprietary code that your development team writes and making sure that your own team is not introducing security defects into the application. Dynamic application security testing, or DAST on the right, is when your application is running, is it vulnerable, right? Are there exploits to be made? Is it possible to hack into the application, to insert data into the database, to intercept traffic or data that's coming in or going out of the application? So that is runtime automated testing that tests how the application behaves. And then the SCA wedge on the bottom stands for software composition analysis, and that's really looking at the composition of your application. What is the third-party content, things that your own development team did not write, and are there security issues being brought in through that now impact your overall posture of your application? So when we focus on open source security, we're focusing on security vulnerabilities in third-party dependencies. So your engineering team has written code. They rely on a third-party library to perform some sort of function. Is that library secure? Does that library comply with your internal policies? When you look at the data that drives this analysis, there's lots of different security databases out there. So the most popular database is the National Vulnerability Database. It is operated by NIST, which reports what they call CVEs, Common Vulnerability and Exposure. So this is kind of an aggregation government-run database, which has vulnerabilities coming from many different sources. Now, NVD is not always up to date with information, so it's important to have multiple sources. NVD, the way that it'll work is it will reserve a vulnerability ID for a new vulnerability, and then it will take a certain period of time for them to perform analysis and score the vulnerability, provide remediation options. So there may be a significant lag between the security issue being disclosed in the news and a record in the vulnerability database explaining what the severity is and how to fix or mitigate the damage from that vulnerability. Given that, there's also many databases that are more ecosystem specific. So things like RustSec, RubySec, GitHub, and GitLab security issues, Debian and Red Hat. So depending on kind of which ecosystems you rely on, it's important to make sure that you track those vulnerabilities as well. Furthermore, each SCA vendor has their own security database. So they will have primary security research teams that assess security vulnerabilities in the industry and correlate vulnerabilities from these different sources along with their interpretation of more of kind of a security advisory that may encompass multiple CVEs under it. Furthermore, we see across our customer base, there's organizations that also subscribe to commercial security reporting services and databases. So it's important that when the security team does their assessment, they have all this information available for them, that it's deduplicated, that it's reconciled, and that they can make an informed decision on whether a particular component impacts the security posture of the application, and if so, what is the actual impact and how can that be mitigated? When you look at how vulnerabilities are scored, there is a system called CVSS, which stands for Common Vulnerability Scoring System. And there are various versions of that. So there's an older version 2.0, there's a version 3.x, and there's a new version 4.0. And the scoring is a little bit different. So today, most of the data available is still version 3.x, and it has 4 different bands, so low, medium, high, and critical. And anything that is above a score of 9 or 8.9 or 9.0 or above is considered critical and requires immediate attention. So that's kind of a nominal baseline scoring system. The next element that is important to understand is, well, what is the likelihood of something being vulnerable actually being exploited or having already been exploited with information available about that exploit? So that's where the EPSS comes in, which stands for Exploit Prediction Scoring System. And it is essentially a percentile ranking of the likelihood of a particular vulnerability either having been exploited or being exploited in the short term. So if you look at the score and how the score impacts your product, and you look at the likelihood of a near-term exploitation, those pieces of data coming together is a great approach to prioritizing which vulnerabilities to look at first and which ones could be made a phase 2 or subsequent set of analysis. Now, when you're talking about open source vulnerabilities, this is not code that your team wrote. So typically, you don't fix open source vulnerabilities. You remediate by upgrading a component. Now, when you upgrade a component, you're typically dealing with sets of vulnerabilities. So if you upgrade from version 1 to 1.1, you may have fixed 20 vulnerabilities and a new set of vulnerabilities may have come in. So it's really important to kind of do research and understand when you are moving to a newer version, are you actually better off, right? Have you addressed the security problems that's causing you to upgrade? And have you not introduced new issues that you didn't consider that may actually put you in a worse state? So it's important to kind of understand the consequences of moving from one bag of vulnerabilities to another. Now, clearly, if you went from X number of vulnerabilities to 0, then that puts you in a better state. But moving to the latest version doesn't always imply that there's going to be no vulnerabilities. It may be that it hasn't been assessed yet, or vulnerabilities haven't been reported yet. So it's important to not kind of do this and forget, but to continuously keep coming back, make sure your SCA tooling has alerting if there's new vulnerabilities, and make sure that you stay on top of this, because the vulnerability state changes all the time, very dynamic. The other thing to understand is that vulnerabilities sometimes can't be remediated by upgrading. So maybe there is not a fix available. Maybe the vulnerability doesn't impact you. Maybe you have to write some defensive code to route around the exploit. So vulnerabilities could be suppressed if they're irrelevant. They can be rescored or mitigated if perhaps they don't impact you in the way that the vulnerability is described. Or they could be perhaps fixed by your team or worked around by writing some defensive code to perhaps process data differently, or add some additional hardening to make sure that that vulnerability is not exploitable. Or ultimately, perhaps you may have to remove a component or replace it with an alternate component to deal with a security issue. Okay, so now that we've talked about licensing as security, let's talk about why lots of people do this analysis. And ultimately, all roads kind of lead to the software bill of material. So think of the software bill of material as an ingredients label for your software application. So it ultimately needs to be formal and queryable, because this is a set of data that is handled between organizations electronically. So it needs to apply to a common standard, and it needs to be machine readable. It needs to have details and relationships of all the software components used in your software, and it needs to be something that is updated every time your application changes. So if you look at the diagram on the bottom here, CISA today is a government entity around cybersecurity, and they are charged with managing software bill of material requirements. They collaborate with both the public and private sector. There's lots of different work groups and discussion threads that are happening, so definitely get engaged. And ultimately, there are two main formats that are being used in the industry today. So SPDX stands for Software Package Data Exchange Format. It is managed by the Linux Foundation, and it is a format that has recently had a major upgrade to version 3.0. The other format that we have is Cyclone DX, that's coming from OWASP, and both of those are fine, right? It kind of just depends on what your company's preference is, or perhaps what your customers are demanding from your organization. So make sure you understand the differences between them, and understand what it is that you need to send out to make sure that the receiving party is able to process, ingest it, and understand the data. When we talk about kind of the inputs and outputs to an SBOM, so typically inputs to an SBOM are going to be all your executables, your commercial libraries, your proprietary software, and your open source components. So a software bill of material is not just the open source, it is all the ingredients inside your application that did not originate in your company. So if you're OEMing commercial packages or libraries, if you have contract developers, if you're working with partners, all of that content needs to be expressed in your bill of material. When you talk about kind of the elements to an SBOM part, so you need to have supplier information. You need to understand who it is that supplied this content. You need to understand all the software components and versions that make up your software. You need to understand the relationship between them. So is component B there because of component A? Because that will give you an idea of how to remediate any sort of issues you may have. You need to know who the authors are. You need to understand what the licenses are driving the use of these components. And then as kind of an additional document, you need to understand what is the security posture of the application given all of this third-party content. Typically, you don't want to commingle security vulnerabilities with the bill of material, because your bill of material is going to be static, release to release, but your security vulnerabilities associated with it can change at any time. So there's typically a companion document that will express which security vulnerabilities are applicable to your bill of material components. We will share these slides, and there's a couple links here from CISA with lots of SBOM resources available to you, and also webinars that we've done in the past that go into a lot more details around the software bill of material. Okay, so I just mentioned that you don't want to commingle security with the software bill of material. So let's talk about how you would let your customers or downstream partners know what is the security state of your application, given the composition of your bill of material. So there is a document called the Vulnerability Exploitation Exchange, called a VEX, and its purpose is to assess whether a known vulnerability that is associated to a software component actually poses risk to your application. So just because you are using component foo and component foo has a vulnerability reported against it, doesn't mean that that vulnerability is exploitable in every single application that uses component foo. So the VEX really sets the context for whether a set of vulnerabilities is relevant to your users or not. And ideally, it is a really great prioritization tool, because if there's a vulnerability that's not exploitable, you don't want your team spending time dealing with it. Instead, they can deal with something that's more relevant, either as part of their internal work or as part of remediating something that is actually exploitable and damaging to your customers. So the way a VEX works is it is a machine readable file that includes details about the product for which it was generated, the vulnerabilities it may have, and annotations explaining whether that vulnerability is exploitable or a false positive, and if so, why, what your plans are as an organization to address a vulnerability that may not have been fixed yet, and making sure that the document is trustworthy. So it's typically signed, it's verifiable, it's got a private key. So the key there is to make sure that somebody doesn't intercept this document and make changes and now change the kind of the security posture of the information for your application. If we look at kind of a diagram of what this looks like, is it's very much a Venn diagram, right? So the first thing you see on the right here is there's a circle of all the various components that are in your application. That is your software bill of material. And these components won't change unless your software changes. So this is going to be static between releases. The bottom circle here on the left is a set of all vulnerabilities that are reported against all these components that are out there in the wild being used by various software companies. Now, this is a moving target, right? These vulnerabilities may change at any given point in time. So again, this needs to be a continuous assessment to make sure you're always looking at the latest state. Now, what a VEX does is it intersects the two contexts, and it now provides a set of components that have a set of vulnerabilities reported against them. And then the analysis is split into two. There is an indication of things that are reported but are not relevant to you because you're not affected by the vulnerability. And it has a set of vulnerabilities that does affect you and provide risk to your organization. So first thing that the VEX does, again, is it restricts the set of vulnerabilities only to those based on your bill of material. And then secondarily, it will then split that off into ones that you have to act on because they are actually providing risk to your product versus ones that are reported, but the way that your product is used or deployed means that they're not exploitable, right? So it's a really powerful tool, and it's a really great way to reduce the amount of data that goes to your customers that they need to pay attention to ensure that they are running secure applications. Okay, so now that we've talked about open source licenses, let's talk about SCA. So SCA stands for Software Composition Analysis. This is a term that was coined by Gartner back in around 2009 or so. Essentially, it comprises products and services that are designed to document your dependency on open source and third-party software to be able to manage the three things that we talked about: legal, security, and reputation risk. So if you are new to SCA, it's a little bit complicated, right? It's a little confusing. So what we always like to do is kind of bring it back to things people understand, which is food. So we always kind of talk about this analogy between SCA and going out for dinner. So if you look at the analogy here and you are in a restaurant and you happen to be looking at a menu, so you have opted into a particular type of cuisine and a particular subset of all the food available in the world to whatever that restaurant serves. So that is very synonymous to a repository, right? Whether you're talking about GitHub or Maven or NPM or Ruby Gems, you're opting into an ecosystem from which you're going to select available components that you need for your application. Now, in a restaurant, when you've ordered a meal, you're now ordering a subset of what is available on the menu for your needs, right? Whatever you want to eat. Well, that's a software application, right? So if you look at an application, you're taking the universe of components available in the ecosystems you play in, and you're picking and choosing the ones you need to make your application function. So now we're constraining the universe to an ecosystem to a subset of components. The software bill of material is really no different than receiving a check at the end of the meal, right? The check will itemize and enumerate everything that you ordered from the menu and how it is comprised, and maybe it's categorized into food and drinks and other categories. So it is an organized set of elements that you had for your meal, or an organized set of elements found in your software application. Now, when we get into elements of a software bill of material, we're talking about software bill of material parts or an open source component. Well, that's a single dish, right? If you look at a meal and what's on your check, it's going to enumerate every plate that was brought out to you to consume. The challenge there is, if all you did was list out the component, you wouldn't know if there's anything harmful inside that component. So this is where we get into ingredients, right? Why do we have nutrition labels? Well, people have calorie limitations. People have allergens that they need to pay attention to. So if you look at SBOM part attributes, it's similar, right? Those are the things that will list out, well, what are your licenses? What are your license obligations? Are there vulnerabilities? So it's very kind of synonymous to, if you have allergies, you can't just blindly order anything. You need to understand what ingredients were used to make that dish. Same thing with SBOM parts, right? You need to understand, are there harmful parts to your business based on your policy? And then you can take steps on mitigating risk from consuming those components. Okay, so given all this, why spend time on open source compliance, right? It seems like a lot of work, and it's just yet another thing that development teams need to do. Well, so OpenChain is an industry organization that really helps provide a framework for companies to get a handle on both licensing and security governance in their organization. It's headed up by Shane Coughlin. It's sponsored by the Linux Foundation. So definitely get involved. Go look up their website and understand kind of the best practices that they have available. But he has a quote that I really like, which is, open source compliance is not a drag on the business, it's an optimization. So what that really means is, if you do this right, and if you do this up front, you're going to save a lot of work on the back end and a lot of disruptions to your engineering team. So when we talk about why spend time on it, is really to manage the risks associated with undocumented use of open source. If you don't know what you're using, if you don't have a catalog of the parts that you're using, well, how can you protect your company, and how can you take proactive action to make sure that you're building secure products? So license compliance risks, security vulnerability risks, operational risks, right? Do you have dependencies that you don't know exist? Well, what happens if that dependency is no longer available? What if a repository goes down? What if a developer stops developing the component? What if you're building an airplane and its service life is 50 years and suddenly the software patches are no longer available? So it's really important to understand what your dependencies are and make sure that those ecosystems are around for the time you need them to be around for. And then remediation risk, right? Time and money. It costs a lot more money to fix something after releasing than it is to catch it as part of your DevSecOps process. So having an open source compliance program really helps you manage these risks and save money at the same time. The two kind of goals are to construct and maintain a complete and accurate bill of material, and to be able to provide trust and transparency to your software supply chain, so to your customers or to your downstream partners, by delivering the necessary compliance artifacts and transparency to them to understand the program that you run and that it is trustworthy for them to be able to rely on your documents. Okay, so let's talk about what are the forces that drive people to do SEA, right? So there's really kind of four buckets, right? So the first one is what we call an inbound assessment. So there is an event that occurs that requires you to look at something before bringing it into your organization. So perhaps you are acquiring an organization, or perhaps you are divesting a part of your business. Maybe somebody wants to use a big monolithic component. Nobody really knows what's inside there. So you want to do a deep dive on it to understand the risks incurred before you allow its use at your company. Or perhaps you have developers contributing to open source projects and you want to make sure that they're complying with your outbound policies. So these are kind of the inbound/outbound assessments that are a little more discrete, right? You're looking at a perhaps a component, perhaps a piece of code, perhaps an entire organization. But this is usually kind of a one-time event, and then the information gathered from that activity is reused in the future. The second one is internal compliance checks. And there's a lot less of this happening now due to industry and customer demand. So we'll talk about that in a minute. But internal compliance checks are really part of your shift left strategy, right? So as part of due diligence, you want your engineering teams to be made aware of any sort of problems as early as possible, because it is easier to fix and costs a lot less money than to fix it downstream once you release an application. Typically, SCA is integrated into the developer tools, right? So developers know right up front as they choose to declare dependencies if there may be an issue with that. It's definitely integrated into the build process. And it is really there to provide early indication of any compliance issues for the engineering team. Optionally, we see a lot of our customers sharing the output of doing SCA work and building this bill material with security teams, with export control teams, just to understand, again, kind of the risk that they may incur by using certain components. Third bucket, industry customer demands. So this is a big one, and this is where there's been a lot of changes recently. So there are industry regulations, and we'll talk about those in detail, that require you to do this work, right? If you want to sell to the US government, you need to provide a bill of material and an application that your process and your output is to be trusted. If you are working in medical devices, automotive, if you're working in telco, right? These are all regulated industries. They all have requirements on how to properly build software. So this is where SBOMs are produced for products and accompanying security reports to express what is the security posture of a particular application. And then the last one's kind of the worst case scenario. This is event-driven, so this is a reactive use case. Something just happened. You found out a component is toxic, or a component has a ton of vulnerabilities, or something really bad reported against it. Well, if you've done the work, all you have to do is go to your system and query, do we use this component? Do we have this vulnerability? You know, are we impacted by XYZ? Which products contain that component, right? You don't want to do this by interviewing engineering teams. You want to do this by going and interrogating your repository and getting concrete evidence that a particular component is in use, and understanding how and when to mitigate or to remediate those particular issues. So I want to turn it over to Mike to talk about how we can help with all these by going through what our services team can offer as a way to either do work on your behalf or to help you get going. So Mike, I'll turn it over to you.
Yes. So hi, everyone. I'd like to spend a few minutes on this slide here to talk about our SCA services offerings. Let's see here. So first, we have our Kickstart service. It's a service that we offer that's bundled with Code Inside product when it's purchased. The objective for the Kickstart is to get you started with simple deployment, basic training. Really, it's meant to get you up and running quickly and easily. Our consultants typically work alongside your team in a shared services approach. We'll provide you with basic installation, with the initial training, plus some best practices advice, as well as some on-hand support. The second service here are deployment services. Similar to Kickstart, we can assist customers with installation. It can be maybe more advanced installation, and also help with configuration and integration of Code Inside with customers' existing systems like LDAP, SSO, continuous integration, etc. Also, we can help with custom scripts and custom reports. For example, scripts to integrate with some existing tool like Jira or Confluence. Next, we have our audit services. Majority of our services business actually comes from audit services. We provide customers with in-depth code scanning and analysis, basically to identify the third-party open source and third-party commercial components, as well as their security vulnerabilities that are found in the code. Most of our audits engagements, they typically fall into two categories. One category is baseline audits and rescans. Here we can have kind of different ways of doing things. We can either come in and we can perform all the baseline, all the initial scans for the customers, and then their subsequent incremental scans or delta scans. We can also train the customers to do the delta scans. We can do the basic, the initial scan only, and then the customers can be trained to do the rescans themselves. And then lastly, we can train the customers to do everything. We're not needed. We're just training them. The customers do everything themselves. They scan their own code, they scan their own Delta scans, but if needed, they can consult us and we'll come in and we'll help them as a needed basis. The second category is mergers and acquisitions. For these M&A engagements, we're brought in as a trusted third-party vendor to do the scanning and analysis. We work with the buyer and the seller. We analyze the seller's code base typically. When we are done, we produce that report containing an SBOM, software bill of materials. That report usually goes to the buyer, sometimes the seller. The buyer then uses our reports to assess the risk. They can decide if they want to proceed with the M&A. Sometimes we find things in there that are critical and cannot be remediated, and the M&A just dies. Customers do use our reports to remediate any potential IP or security issues. They use our reports as a leverage to negotiate the price of the M&A deal. That happens a lot as well. Lastly, here we have advisory services. You can see them here. We can help customers with remediation. This is we're given an inventory list or an SBOM. We can help with or provide remediation advice. We're not lawyers. But we've done this long enough where we know what most of our customers are doing in certain cases, and we can provide those best practices, the best recommendations for those compliance issues, based on how the industry handles those. OSPO related services. Again, this one here, we work with customers. We provide them guidance. Again, standard recommendations. We can help you with open source policies that Alex mentioned earlier, remediation, scanning, automation. We can consult your team on how to set up their roles and responsibilities as well. We help customers with preparing third-party notices report. This is to comply with the open source attribution requirements. And lastly, here we can generate and produce SBOMs for customers when we're asked to do that. We can do that in a human readable form or in a format that's acceptable in the industry, like the SPDX or Cyclone DX. Yep, Alex.
Perfect. Thank you, Mike. So if anybody has any questions related to services, please put them in the chat and we'll be happy to address them. Okay, so let's talk about some key trends, right? If you look at the top right of the slide, this is coming directly from Mike's team's work. So we're seeing a lot of kind of upticks in the metrics that we track year over year. And we're really seeing kind of four trends that are really driving those numbers to go up. So first of all, if we just look at how big are the code bases that customers are having to scan, well, we're 140% up from last year, right? We're seeing more than doubling of the volume of the files in a code base. Lines of code, same thing, right? We're seeing a big increase, about 125% from what we saw a couple of years ago. And then if you look at binaries, same deal, right? So there is more code, there's more files, there's more binaries, larger code bases yielding to a larger bill of material. So why is that happening? So first of all, we're seeing a lot of generated code. We're seeing lots of Gen AI tools being used. They're getting really quick adoption by development teams. Things like Copilot, Deep Code, Code Guru, IntelliCode. There's lots of different tools out there. And we are seeing kind of a bottom-up movement where individual developers are opting into tools. We're also seeing that kind of a top-down movement where companies are formally evaluating certain technologies with guardrails and trying to find a tool that works best across their company. And we're kind of seeing the two collide in the middle. So lots of generated code that we're seeing in the code bases we scan. We're seeing a greater focus on security. So things like security by design, by default, zero trust principles. These are all things that are becoming more top of mind. And therefore, there's there's work being done by bringing in additional code around security to make sure that products are secure from the beginning and not that security is bolted on at the end. We're seeing a need for import, deduplication, and reconciliation being really critical, right? So we're seeing a lot of tools being used. A lot of our customers have multiple SCA tools being used, multiple security tools being used. How does all that come together? The reason they use tools is for completeness and redundancy in some cases. And the context for your bill of materials really matter, right? Are you looking at an SBOM for software? Well, what about the hardware? What about the SaaS? What about your AI data models, right? What about your LLMs? What about supply chain, right? If you're OEMing something, or if you have contract developers working on your behalf, are you looking into their code and are you merging that together with the work that you do in-house. So understanding context and being able to take data in and correlate it and associate it and reconcile it with the data that you produce is critical. Otherwise, you're chasing lots of duplicates and lots of excess data. And then, clearly we're seeing AI-powered development is leading the way, right? So AI, machine learning, large language models, all these apps use lots of open source content. They run in third-party clouds in some cases. They run in public clouds. There's client interfaces built to models and services. So it's important to understand, well, what's inside the LLM. There's typically a much greater percentage of external code, but smaller LLMs being used these days. So again, it's just another another channel of why third-party content enters modern application code bases. So Mike mentioned that we have some OSPO services. So let's talk about what an OSPO is. So an OSPO stands for Open Source Program Office. Over the years, there's been different names for it, but ultimately it is a cross matrix team of various stakeholders that are in place to be able to ensure that you have open source compliance within your company, and you're being strategic about both consuming and contributing to open source ecosystems. Typically, we'll have representatives from engineering, product, legal, security. There may be additional stakeholders. In some cases, you may have advisors from outside the company. In some cases, you may have a single person running the whole thing if you're just getting started. So an OSPO is charged with creating an open source compliance strategy and a set of processes, roles, responsibilities, accountability that really determine how a company will implement these rules on a continuous basis. The strategy is really all about what must be done to ensure compliance and what are the governing set of principles for how your employees will interact with open source software, both in consumption use cases as well as contribution to open source ecosystems. And as a result of the work, you should have formal processes for approval, acquisition, the use of open source, and a method for releasing software that contains open source or licensed under an open source license. So there's a link here to a Linux Foundation article that really goes through lots of these points. And there's a lot of different industry groups around kind of OSPO best practices, support, and having companies kind of share best practices to make sure that you're not reinventing the wheel if you choose to start one of these up. Also, if you go look at OpenChain that I referenced earlier, there's lots of great content there around kind of key elements of open source program offices and best practices, both from legal and security perspective. Okay, so kind of given all this, where are we today, right? We want to kind of talk about what's happening in the industry and industry regulation. So we're kind of at a point where the use of open source is growing, and we kind of explain why, right? We're up to about 3,500 pieces of open source in a standard application, and typically that accounts for 80% of or more of a modern application's content. So that just means that you really have control over about 20% of your product. The rest needs governance. We're seeing that there are a lot more security exploits, and the security exploits are not just increasing in volume, but they're increasing in sophistication. If you look at past kind of well-publicized security exploits, this is not a single individual sitting there manually hacking a website, right? We're talking about foreign entities. We're talking about lots of funding. We're talking about supply chain attacks where something is attacked as part of the development process, and then an exploitation is invoked, weeks or months later. So very complicated, lots of investment in this. So you need to make sure that your teams are trained and they're keeping current in their knowledge, and that your best practices address the risk. We got SBOM mandates, right? We got the United States Cybersecurity Executive Order. We've got the EU Cyber Resilience Act. There's lots of worldwide regulated industries with various entities around financial, medical, transportation, energy, automotive, publicly traded companies. So we'll go into a little bit more details on the next couple slides. And why is this a problem? Well, because we have a very disconnected supply chain. There's a large lack of transparency into software supply chain, which is different from your typical supply chains, right? If something happens to a Boeing airplane, they know every single nut and bolt and subassembly and every part that's been manufactured, who created it, who assembled it, and how it ended up on the plane. There's just not that level of tracking for software. So that causes lack of transparency and causes kind of lots of unknowns unless you have your house in order and your entire supply chain is secured. And ultimately, it's important to understand that you're liable for what you distribute or host. It doesn't matter that somebody made a mistake developing a component. If you're using it in your product, you are responsible for making sure that that code is secure for your customers and downstream partners. So let's talk about regulations real quick here. So there are two kind of overarching policies. There is the United States Cybersecurity Order from back in May of 2021, and in Europe, there's the Cyber Resilience Act from 2022. In principle, they are similar, right? The idea is to set up some overarching policy across a kind of a large region. It is focused around government and government-regulated industries. And ultimately, it is a very broad kind of set of regulations around overall increasing the security posture of government. It talks about procedures, it talks about tooling, it talks about accountability, about reporting, and about artifacts that are required to pass across companies to be able to communicate better. The EU Cyber Resilience Act is a little bit ahead, although it was kicked off a little bit later. It is expected to be fully implemented in 2026. On the US side, there has been some lag because there's been budget staffing issues with certain entities. And we are getting to a point now where there are requirements maturing. So we're kind of shifting from non-binding best practices to having hard requirements on what do you have to do if you're selling to the US government, US military, and what documents do you have to provide, what assurances you have to provide, and how do you go about doing so. So again, this is kind of real high-level blurb. There's lots of content available to research, so please make sure that your teams understand this and what role you have to play. Next, let's talk about public sector. So if in the US you are selling to the US government or US military and your software was developed after September 2022, any new version or any major upgrade requires you to attest to 4 things. So number 1 is, was your software developed and built in a secure environment? Number 2, did you make a good faith effort to maintain trusted source code supply chains? Meaning, is your code protected, right? Is it easily obtained and modified by somebody outside your company? Have you maintained provenance for third-party and internal content that is incorporated into your bill of material? Meaning, do you control and do you understand the flow of code that makes it into your product? And do you have automated tools or comparable processes that check for security vulnerabilities? So a lot of common sense here, right? Nothing crazy. But if you look at any of these bullets, that really fans out into lots of different things, right? And you really need to make sure that your security teams have a framework that they're using, that people are trained, that people are continuously trained, and that you've got both automated and manual tooling and processes to make sure that all 4 of these things are being done. Now, this attestation needs to be signed by either the CEO of your organization or a legal designee within your company. And in cases of negligence, this could be personal liability issues involved with whoever is signing. So it's really important before you have anybody in your company sign that you have proof and that you have knowledge of how you're complying with all these requirements, that things are documented, and that if somebody comes and asks, you have a way to demonstrate that you are in fact doing all 4 of these things. And there's links on the bottom here again to read about more information about the form and the repository where the forms are to be uploaded into. Publicly traded companies, right? So if you are a publicly traded company as of December of last year, you are now required to incorporate cybersecurity into your quarterly and annual reporting. So publicly traded companies file 8K reports whenever there is a material event and 10K reports annually that express all their financials and any sort of risk to future financials. Well, as of December last year, cybersecurity is another criteria that has to be expressed in these reports. So there's been a couple of prominent cases by Clorox and MGM Resorts where there have been hundreds of millions of dollars impact to bottom line due to cybersecurity events. And they did all the right things, they made all the right filings, but this is a process that if you are a publicly traded company, you need to make sure that your engineering team and your security teams are connected to your finance teams or to whomever's responsible for the reporting to make sure that that chain of communication exists, because you really only have 4 business days from learning about an event to where an 8K must be issued. So again, there's links here to understand this better, but this is kind of new regulations as of December last year and impact any publicly traded company out there. And then finally, I just wanted to talk about medical industry, right? So medical industry has lots of regulations, both in the US as well as in the EU. US, we've got the FDA that regulates cybersecurity requirements. In the EU, we have the medical device regulations, or the MDR. Ultimately, they emphasize two things. They emphasize managing cybersecurity risks throughout a medical device's entire life cycle. And it typically splits into two phases. There's a pre and a post-release set of requirements. So in the US, any medical device that is networked or that contains software, so any sort of smart medical device, needs to demonstrate reasonable assurance of cybersecurity procedures and testing, including production of bill of materials, before it is released. And after it is released, the focus really shifts to monitoring, identifying vulnerabilities, and addressing vulnerabilities and exploits through patching and remediation. And if you look on the EU side of it, it applies to manufacturers, to authorized representatives, importers, distributors, so essentially anybody part of the supply chain, to make sure they can identify vulnerabilities, make sure they design, develop, and maintain devices with robust cybersecurity features, and they have a way to patch and remediate issues as they are discovered in the field. Okay, so again, real kind of quick flyby on a lot of these topics, but there are lots of links in the slides that take you to additional information if you want to read up on it. And at this point, we are happy to take any questions. So let me look at the chat. I know we had a couple questions come through earlier, so let me read through those. So one of them was, how does one actually get started if they are new to SCA? Right, so it's a really good question. Kind of there's lots to do here, but ultimately I always kind of like to talk about a three-step process. So the first step, the first process starts with governance, right? So make sure you operate within a security framework. So work with your security teams, make sure you adhere to the NIST Secure Software Development Framework or another framework of your choosing. Make sure you're doing SCA, make sure you're doing static testing, make sure you're doing dynamic and automated testing. Make sure that every team is trained and educated. Number two, we always talk about develop your policy. So if you don't have a policy, work with your legal security teams. If you need help, reach out to our services team. You need to have a policy that governs use, roles, responsibilities, and consequences for failing to comply. And really understand that including code from anywhere without validation is just not an option anymore because it puts too much risk on your company. And then the third step is generate SBOMs, right? There's lots of tools out there, both commercial and free. You don't have to use one. There's lots of them that are kind of good for different ecosystems, use many, but have actionable SBOMs that help you quantify your risk. And most importantly, alert you with changes over time, right? Because again, security vulnerabilities change all the time. So it's important to make sure that you've got alerts in place. Second question, very relevant that I saw come by, is how can SCA help with Gen AI generated code? So Mike, I'll let you handle that one.
Sure. The snippets for the Gen AI generated code, written by tools like Copilot or ChatGPT, they've been collected from various places on the internet, many places. And our team, when our team performs the audit, like specifically we're talking about a forensic level audit. We have different types of audits, but forensic level audit would get you to the snippet level. And so when we do that type of engagement, we try to identify and report on any findings, associated with those snippets. And so all in all, the SCA can ensure that the Gen AI generated code is, first of all, identified, right? Once it's identified, then the lawyers can decide if it complies with open source licenses or any other legal requirements to avoid the issues that can arise from using improperly licensed code.
Okay, fantastic. So thank you all for joining. We've hit the top of the hour. And as I mentioned, this is being recorded, so this will be made available in a few days. And look out for additional webinars coming out from us very soon. Have a great day.
Thank you.